right, we're going to do two problems here, and in both of these problems we're going to have the same directions. Find the perimeter of a rectangle with the given area. All right, we see that our area is a polynomial, 5x to the 8th power plus 15x to the 4th power. So at first we might kind of look at this and think, well, we don't really know where we're going here. But we know that if we're finding the area of a rectangle, we know that that's length times width. So we need to find two numbers, or actually in this situation, because we're not just dealing with numbers, we're dealing with polynomials, we need to find two expressions that multiply together to be this area, to be our length and our width, because then we can use that length and width to find the perimeter of our rectangle. So we need to use what we've been doing here lately this week, and we need to factor this polynomial. I see there's only two terms. It's not set up like MARF. We know MARF is x squared plus x plus just a number, so that would be 3 terms. And factor by grouping is 4 terms, and so this doesn't meet either of those qualifications. So what we're going to do here is factor out a GCF. All right, so we know that the biggest number that goes into 5 and 15 is 5, and then we take out the x with the smaller exponent. So 5x to the 4th power is the GCF of these two terms. But since we're factoring it, since it has a plus sign in the middle, we need to go ahead and do our parentheses and think about what's left over inside the parentheses. 5 divided by 5 is 1. X to the 8th power, I took out x to the 4th power, so I'm left with another x to the 4th power. Okay, I'm subtracting those exponents. Now I do division again. 15 divided by 5 is positive 3. X to the 4th power, and I took out x to the 4th power, so I don't have any more x to the 4th powers. So this is completely factored right here. All right, so what we're finding then is this area is made up of these two separate factors, 5x to the 4th power and x to the 4th power plus 3. This we can think of as our length and our width of a rectangle. So I'm going to go ahead and draw a picture of a rectangle. Sometimes it helps to look at it at a picture. So I'm just going to label one of the sides 5x to the 4th power, and the other side is x to the 4th power, and you can put the 1x to the 4th power if you want, plus 3. All right, to find the perimeter of this rectangle, which is ultimately what we're trying to do, we need to add up all the sides. We know that perimeter is the sum of the distances of all the sides. So I know this is 5x to the 4th. It's a rectangle, which means this is also 5x to the 4th power. Okay? And if this is 1x to the 4th plus 3, then this is also 1x to the 4th plus 3. So I just need to add up all of these sides. So the perimeter equals, and I'll just start here, 5x to the 4th power plus 1x to the 4th power plus 3 plus 5x to the 4th power plus 1x to the 4th power plus 3. So I got to remember to do 2 of each side, not just 1 of each of those sides. All right, so then I'm going to combine my like terms. I see 5x to the 4th, 1x to the 4th, 5x to the 4th, 1x to the 4th. So that's 6, 11, 12. So 12 x to the 4th power. We remember we don't change exponents when we're combining like terms. Okay, and then I see I have a 3 plus 3. So this is plus 6. So the perimeter of this rectangle is 12x to the 4th power plus 6. Okay, so a rectangle has an area of 5x to the 8th power plus 15x to the 4th, has a perimeter of 12x to the 4th power plus 6. Okay, so this was using the GCF. Now let's look at another example. All right, again, we have the exact same directions. Find the perimeter of a rectangle with this given area. All right, but now I see that this problem is set up where I have an x squared as the first term, an x, and then just a number. So what I'm going to want to do here for sure is MARF. I see that this is set up to do a MARF. And again, area equals length times width. So I'm looking to find my length and my width so I can find the perimeter. All right, so let's go ahead and go through our MARF steps. We multiply 2 times 4, and we get 8. We add to be the middle term, which is 6. So I'm looking for my 2 magic numbers here. I'll give you just 1 second to think. Okay, we're looking for things that multiply to be 8 and add to be 6. All right, I'm sure that you all got that. That is 2 and 4. All right, so 2 times 4 is 8. 2 plus 4 is 6. Now I restate my polynomial, and instead of this middle term being 6x, I'm going to use my 2 and my 4. So 2x squared plus 2x, and I have to remember to put the x on there because it's in the middle, plus 4x, and then plus 4. Okay, so then we're going to finish this up. Our last step is to factor by grouping. We group the first 2 terms and we group the last 2 terms. I see here I have 2 and 2, so I know I can factor out a 2. I have x squared and x, so I factor out the x. 2 divided by 2 is 1. X squared, I took out an x, so I still need an x. 2x divided by 2x is going to be 1. Right here I have 4x and 4. They don't both have x's, so I can't take out an x, but I can take out a 4. 4 divided by 4 is 1x. 4 divided by 4 is 1. Okay, and for my last step, I take my 2 that are outside the parentheses, I combine them, 2x plus 4 times x plus 1. Okay, so this is a different format of the original polynomial. So this is just a different way of expressing that area. All right, again, we know that area is length times width. All right, so now I have a binomial, 2x plus 4 for my length, and a binomial, x plus 1 for my width. All right, so let's draw a picture again. All right, 2x plus 4, and it doesn't matter which one we label which. Okay, and x plus 1. And I have to remember to take into account all 4 sides when I'm doing the perimeter. All right, so now I set up my perimeter. Perimeter is the sum of the sides. So x plus 1 plus 2x plus 4 plus x plus 1 plus 2x plus 4. Okay, so I add up all those sides. I see x, 2x, x, and 2x. So this becomes 6x. Okay, and I have a 1, a 4, a 1, and a 4. Okay, so this becomes 10. So 6x plus 10 is the perimeter of this rectangle. Okay, you've got some practice problems to try on your own now.